Hello everyone, happy holidays and welcome to the OneClass channel. My name is Fajori Rome and I am an Honors Bachelor of Science student working towards medical school. Today we'll be going over some commonly asked chemistry questions at both the high school and college levels. If you need some homework or help or tutoring you can actually click on the link in the description below. And with that, thanks to our introductions, we can now officially begin this session, starting with question 1. So, as you can see, the first question asks, if it takes 5 years for Juno to reach Jupiter, what is the average speed in miles per hour over this period? So, question 1. Alright, so 5 years. And they want to know average, that's bad writing, average speed in miles per hour. Let's actually zoom in here so my handwriting can be a little bit more crisp. So that's the whole question there. And if you want to see it here, you can see it on the other screen. So with that, let's begin. So first, let's break down based on the information we had. It took her 5 years and they want to know her speed in miles per hour. So 5 years is the time, okay? And so we need to convert 5 years into hours. So the way that will work is that, well, we definitely need a calculator for this one, but we need to know how many hours in a year, and then we just multiply that by 5. Make sure you keep your units. So with this, actually, you can just, if you're given conversion sheet, that works a lot easier. But this one's a little bit tricky when it comes to time because it's usually easier to search it up. But simply put, how many hours in a year? So this is what they're giving us. There's 8,760 hours per year. And the reason why I wrote it like that is because it's important to keep your units. And you know what? While we're here, they're asking us specifically in this question, Juno to reach Jupiter. We're assuming that they're starting from Earth, okay? And so distance from Earth to Jupiter. So we have 799.04 million kilometers, which is actually perfect because this helps us with our conversions. So we're given now the way to do these questions. You need distance over time. That's how you calculate speed. Okay, so actually I'll write it here. So velocity, velocity is a little bit different because it includes direction, but speed is equal to distance over time. Okay, and now that we have that information, we're given the distance and we're given the time, 5 years. Okay, so now we have to work on converting this. I'm going to use a different color so we can keep track. So let's work on distance first. They're asking for average speed in miles, not kilometers. And now here's where, if you do have a conversion sheet, that's great. I actually pulled up some conversion sheets specifically for this because in this lesson there will be quite a few conversions. So here we have it. So for length, 1 mile is 1.609 kilometers. Okay, so with that, okay, so we want it to go from kilometers to miles. So the way I do it to keep my units, it's actually like this. So I have, let's write down a lot simpler because 799 million, so that's times 10 to the 6. So I really have 799.04 times 10 to the 6, because 10 to the 3 is 1,000 because that's 3 zeros. Okay, 10 to the 6 is 3 more zeros, so that's 1,000,000. That's how we figure that one out. So with that, let us continue. In order to make this a much nicer number, I'm actually going to move some digits around. going to move this over here twice, and by doing that, I actually add 2 here. So the actual distance we have right now is 7.9904 times 10 to the 8 kilometers. And now we want to convert it to miles. You always want to put the thing you're trying to convert to in the numerator. So it's 1 mile. And according to this sheet, it equals 1.609 kilometers. And the reason why we do that is because we want to make sure that units cancel out. Numerator, denominator, there. So by dividing that number by 1.609, we will get the amount of miles. So I'm going to quickly put this in my calculator. Okay. .609. So we get around 4.966, well, times 10 to the 8 miles. All right, so we have our first number, okay? And now we want to get that time. It says miles per hour. So like they discussed earlier, we have 8,760 hours per year. So now you want numerator and denominator the same way. So 5 years, okay, times 8,760 hours in 1 year. Okay, so what does that give us? 5 times 8,760. This is the amount of total hours we have, 43,800. Okay, and that means we have now hours and we have now miles. So now if you want to match the miles per hour, you have to divide the miles by the hours. So now we have 4.966 times 10 to the 8 miles over 43,800 hours. And then you just plug it into the calculator. All right, so we have 1.1338. I'm just going to round it there. And then we'll discuss significant digits after, but I just want to get a number real quick. Times 10 to the 4 miles per hour. And now back to the original question. So there we go. It says 5.0 years. The reason why now significant digits matter, they only gave us 2 with the 5.0. So here it's really the answer is just 1.1 times 10 to the 4 miles per hour. That should be the answer. Let's see how to discuss it. They do discuss speed equals distance over time, which is correct. They have that total miles based on, yep, the kilometers. Our kilometers were a little bit different because I pulled it straight from Google. But as long as our numbers are relatively in range. So I get 1.1 times 10 to the 4, and they got 10,901, which coincidentally is, if you round it, it is 1.1 times 10 to the 4 miles per hour. So this is correct. And with that, we've answered our first question of many in terms of how to work with units.